Hello, welcome to another episode of Generation STEM. To those of you who are watching us for the first time, I can tell you that this is a series aimed at awakening the interest for those careers related to science, technology, engineering, and mathematics, or STEM. I am Gabriel Salgado, and I will be with you in this journey through the fascinating world of STEM careers.
Generation STEM is brought to you thanks to the help from the National Science Foundation and its collaborative association with the Center for Games and Impact, VEME, Eline Media, Haku, and Arizona State University.
Today in Generation STEM, we are going up the mountains with a geologist who will show us how to read the history of our planet written on rocks. A young Puerto Rican meteorologist tells us how her love for science took her to the National Hurricane Center. Stones are the tools that an enthusiastic geologist uses to find hidden mysteries of our planet. An organization opens its doors to Hispanic students to help them start the road to achieving a college degree. All this and more, today on Generation STEM. Let's start our first segment of the day with geology, a branch of science that is dedicated to unveiling the mysteries of our planet, its composition, and all those processes that are constantly changing it. To talk about all of this, we have Angel Garcia Romero, a young Puerto Rican geologist who will show us how rocks can tell us about our past and our future.
We think of ourselves historians. Historians that they look the past, historians that try to understand the present, and historians that they want to understand and know clues for the future. My interest in geology specifically started when I took my first geology class as undergrad in the first year, and we started studying how Puerto Rico was formed geologically, how the karst were formed, how volcanoes, metamorphic rocks. It just gave me that spark. I discovered that passion for geology when I spent almost 2 weeks in Yellowstone, where there was no internet, there was just the books, and there was just the experiments. And I got so into it, I was like, I think I want to spend the rest of my life doing this. The reaction of my parents was pretty unique. My dad loves hiking, and he thought that what I was doing from now on, it was part of like recreational activities, and because they never been into college and they never understood what was sciences at their age or at the level they finished school, 3rd grade and 6th grade. I have many friends in the complex I used to live. We call it Caserio. It's a public housing funded by the government. In my case, it was funded by the federal government from the United States. Growing up, it was easy in that way when I was still in the grade levels. But when I reached into high school, because of drugs and violence, I lost so many friends in that environment. We are here at Hayden Butte, better known as A Mountain. This part of the preserve of the Tempe City. Here we see sedimentary rocks, 2 kinds of main sedimentary rocks. The first one that we see here, this hard rock, is what we call sandstone. It's made of sand. And here we see another one that is more softer that we call mudstone, that is made of mud. So understanding the rocks that we see today, more than understanding what was the past in our planet, also we can extrapolate the same conditions, the same rocks, to understand what was the past history, past environment of other planets. When we see sedimentary rocks in other planets, that can give us a clue that it was water depositing the stuff, right? In part of geology, being an historian also is a person who looks at the future in this sense. Is trying to understand how water that is connected with the magma, for example, in Yellowstone National Park, in supervolcanoes. Growing up, I understood that it was really important, as right now, also as an educator, that math is important. More important is the analyzing or the analytics that you may have. In this way, it is not just about numbers. It's about kind of like have that metacognition of putting stuff together, you know, a good background in physics, a good background in chemistry, be interested in those stuff that can be complemented. Understanding the geology here is just not for us. It's just not for understanding the planet. It's a thing that we want to know, that we want for sure to have a good idea, but also is to understand the other planets in our neighborhood and how can some of them have life on them, and some of them that will be friendly to visit one day.
It has been said that in order for us to understand our present, we have to know our past. This is what geologists like Angel try to do every day. As you saw, the offices of these professionals are caves and mountains. That's why this profession is ideal for those who love science and nature. For more information about this and other STEM careers, you can visit our website, primotv.com/generation-STEM. Here you can find all kinds of help, from selecting a major to finding financial aid, and much more. When we return, a bright meteorologist tells us about her involvement in a project to build a new satellite. Now we go to the National Hurricane Center, which is like the headquarters for the scientists who track storms and closely watch all kinds of activity in the atmosphere. Nelsie Ramos is one of those people responsible for weather evaluations during the hurricane season to help us stay safe. She also helps predict conditions at sea for sportive and commercial activities. Nelsie explains how she does her work and what happens inside the Hurricane Center.
My name is Nelsie Ramos. I'm a doctor in meteorology, and I work for the National Hurricane Center, Tropical Analysis and Forecasting Branch. In the National Hurricane Center, as a marine forecaster, I analyze the current conditions and forecast the future condition, synoptic condition, mesoscale condition, as well as wave and winds across the tropical and subtropical oceans. I started with a bachelor's in computer science from the University of Puerto Rico and Maya West. And after finishing my college, I went to Washington, D.C. and to Howard University and did a master's degree in atmospheric sciences, then with a focus on tropical cyclones. And then I decided to continue a PhD and also with a focus on tropical cyclones and data simulation. In the Marine Division of the National Hurricane Center, known as Staff B, in the analysis desk, we analyze the current condition of the atmosphere in the tropics and subtropics, and we evaluate, analyze the features that may have an impact on these transoceanic vessels and navigating through these oceans, and where the hazard zones are for them, so they can change route if necessary to save their life and the property, since 90% of commerce is through these vessels. I ended up in meteorology through a professor. It was a suggestion from a professor when I was doing my college, and it was from a minor degree that I was doing from NASA program. He approached me and he suggested me, why don't you focus on the meteorology, atmospheric science area? I wasn't even interested in doing graduate studies at that time. And even I didn't even know what atmospheric science were. I wasn't know that it was related to meteorology, but I always have that interest within me because I experienced hurricanes in my island, tropical cyclones in Puerto Rico. To work for the National Hurricane Center, I think you gotta have at least a bachelor's degree in a STEM field. It is very competitive on these days, so a master's degree highly encouraged. And if a student may get experience through an internship in any office, like weather office that deals with tropical weather forecasting, that's a valuable thing, that highly considered for working here. Here at the National Hurricane Center, we start studying any system that analyzing the conditions of any system that may form in the Pacific, starting from May 15 through November 30th, in the Atlantic from the June 1st through November 30th. So we are always monitoring the 24/7 the atmosphere, and in any area of particular concern for the specialists, for us in the Marine Division, we try to get the position of a system, the intensity of a system, and give that information to the hurricane specialists so they can in detail study that system and see where that system is going to develop or not, and where it's headed to. This is the Miami Weather Forecast Office, and as you can see, there are a lot of monitors. They are aware of what is going on, not just in the news, and what is going on in the weather in other parts of the world as well. And you can see, they look for radar imagery, satellite imagery, and all these kind of model fields to determine if there's going to be hazard condition inland the Florida Peninsula, and also in the coastal water within 60 nautical miles offshore. Here, the Weather Forecast Office in Miami have displayed one of the two hurricane seasons that have most of the impact, not just for the Florida Peninsula, but also for the Gulf Coast. Examples of those tropical cyclones are Frances 2004 and Katrina in 2005. Meteorology is a well-paid career, I believe it is, and you have chances to grow in the field and get to different levels, management level, different. You can diversify your portfolio while you're a meteorologist.
Math, computing, and her love for meteorology were the foundations of her successful career. Like her, many other young women have access to this field that was, until recently, mainly studied by men. Nelsie and her colleagues are paving the way for new generations to get into this profession. When we return, we'll meet a young geologist devoted to detecting bacteria that lived in rocks billions of years ago. In this segment, we'll give a rest to rainfalls and hurricanes to talk about geology and another practical use of the profession. Marisol Rivera is a young student who always loved science. She started as a civil engineering student, and one day she had a class that changed her path completely. Today, she is working on her doctorate in geology, and as if she had a time machine, she takes a stone in her hands and goes back in time to find its origins. Let's hear her story and her amazing journey.
My name is Marisol Juarez Rivera, and I'm a PhD student here at ASU studying geology. More specifically, I'm studying early life on Earth. I got interested in geology by taking a course in undergrad. I started undergrad as a civil engineering student, but after taking a geology class and seeing how the rocks are forming, how the environment shapes the rocks, and in turn how the rocks shape the environment was something really interesting for me. I wanted to learn more. And after I took that class, I started taking more geology classes, which eventually made me interested in early life and how early life is preserved in rocks. Right now, what I'm working on is studying how life is preserved in rocks. And that's important because if we know how life is preserved in rocks now, we can actually go deeper into the geologic record and try to understand what life there was on Earth before there was humans, before there was plants. But also because if we understand how life can be preserved in rocks now, we can take the knowledge to other planets and try to study if life was present there. So as a geologist studying early life, this is one of the rocks that I look at. So this one's called a stromatolite, and they can form in the bottom of the ocean or on a lake. And the interesting thing about this stromatolite is that you need life for it to form. So for example, each one of these lamina that you see here, they curve up and they start forming a mound because there are sticky bacteria there that were living, and sediment was raining on top of them, and they were holding on to the sediment and growing on top of it. And as more sediment grew on top of it, the bacteria kept moving upwards. So that's how they formed these columns. This is a site where you don't have a lot of columns, and it's probably because there wasn't a lot of bacteria there. So there you just have normal sedimentation filling in the void with sand. But here, you needed the bacteria to hold on to the sand. So this is a process that happened throughout history. So we can use stromatolites to go back in the geologic record and study the life that was there. The process of getting to college was a bit tough. I am the first in my family to go to college, so I had to lead the way for myself quite a bit. My parents didn't speak English, so it was really hard for them to help me, even though they tried. So I got a lot of help from my school mentors who showed us how to apply for the FAFSA, how to apply for fee waivers to apply to the schools. And it was really a community effort between my teachers and other students in that class, because we would help each other. I chose to go to school in UC Davis because it was close to my parents. It was about an hour south of my parents. So I felt good because I could visit on the weekends pretty nicely without having to travel a lot or spend money. Right now I am working in hot spring systems. And these hot spring systems are important because the water precipitates minerals. The mineral that I'm studying is silica. And as the mineral precipitates, it encapsulates any life that is present in the hot spring. I am going to go to Chile to study hot spring deposits in El Tatio. Now, El Tatio is not as beautiful as Yellowstone, but the way that the minerals precipitate in the hot springs of El Tatio are really, really reminiscent of some of the structures that we see in Mars. If you have a strong chemistry background, there's a geology job for you. If you have a strong biology background, there's a job in geology for you. If you have a strong background in physics, there's a big job for you because physicists and geologists come together to study earthquakes. So any background that you have fits really well within geology.
How thrilling it is to find the beginning of life on our planet based on what stone cracks tell us. Marisol travels around the world studying rocks, something that allows her to grow as a professional and increase her knowledge. Remember to visit our website for more information about STEM careers, how to get ready to go to college, and all kinds of information related to financial aid and even scholarships. When we return, an international association opens its doors to Hispanic students to encourage them to be a part of the STEM universe. Now we are going to visit an important international association that represents more than 450 colleges and universities all over the world. Their objective is to promote undergraduate studies for Hispanic students and to help them access different colleges. Antonio Flores is the president of HACU, and he is going to talk to us about the importance of STEM careers in our world today.
HACU is a national and international association that advocates on behalf of Hispanic university students before the United States Congress and federal government, so that they will assign more resources towards our universities, so that these in turn can more successfully help in preparing and graduating Hispanic students from different parts of the country. As an association, we integrate more than 450 universities here in the U.S., which have a noticeably high enrollment rate of Hispanic students, and we are currently affiliated with universities in 37 states and Puerto Rico. And now we also have an international chapter that includes Mexico, Central America, as well as some countries in South America, the Caribbean, and Spain. Our goal is to help our Hispanic students in the U.S. have more opportunities to study abroad, as well as assisting students in Latin America to come study over here in the United States. Now we are focusing more on the area that we call STEM, which are careers based on science, technology, engineering, or math. We are putting more emphasis on those career paths because statistics tell us that in the current labor market in the United States, they have a higher demand, and it will continue to increase in the next several years. So obviously that we are responding to the needs of the economy. One of the most important programs we currently have are our internships or work studies, which give the young students a very, very special chance to put into practice all the skills they've learned before they graduate. We have internships at federal agencies and corporations, and those go for about 10 weeks during the summer or 15 weeks during spring or fall. All of them fully paid.
STEM involves every aspect of life, from education to business and also health. STEM in general is in the group of careers that is growing more in comparison to other fields like humanities and other businesses. And we're going to need professionals in those jobs. What happens to the students is just that they need a foundation that's very advanced in mathematics and science, and they have to begin in high school. It is very important that the parents take part in this decision to support the student and to go to the counselor and tell them, this is the plan for my child. Every student has an opportunity to go to the university if that's what they want to do. You just have to find those resources. The last resource we tell parents, yes, there are loans, but education is the only thing that will increase in value over time.
Over the 20-plus years of our program, we have placed over 11,000 students. The vast majority of them are now dedicated, great professionals who are very successful.
As you can see, STEM careers are among the main priorities of this association. Statistics show that professionals in any of STEM disciplines are growing in demand in the United States. This is why it's so important to have a good foundation in math and science from elementary to high school in order to go to college. We invite you once again to visit our website for more information about STEM careers, colleges, financial aid, and everything related to getting access to higher education. That's all for today, and thank you for joining us in the exploration of science, technology, engineering, and mathematics. I hope to see you in our next episode of Generation STEM.